Okay, now it's time to begin a new chapter. We're going to start out by learning about parallel lines and their transversals. So the Common Core Standards we'll be discussing, GCO 1, and the Mathematical Practices 1, make sense of problems and persevere in solving them, and 3, construct viable arguments and critique the reasoning of others. Previously, you've used angle and line segment relationships to prove theorems. You remember that was in the last chapter. Now we're going to identify relationships between two lines or two planes, and we're going to name the angle pairs formed by parallel lines and transversals. Got quite a bit of new vocabulary. Some of it's not so new. Parallel lines, skew lines, that might be a little different for you. Parallel planes, a transversal, interior angles, exterior angles, consecutive interior angles, alternate interior angles, alternate exterior angles, and corresponding angles. So now we're going to discuss the relationships between lines and planes. And we have a couple of key concepts here. Notice that this symbol means parallel lines, so you'll need to make sure you notice that. And also arrows. See these pretty pink arrows? They're used to indicate that lines are parallel. So if we're not told they're parallel, if we're not given this symbol, we could be shown that they're parallel by the markings. Now skew lines, they're lines that do not intersect and they're not coplanar. So notice that line L is in plane A and line M is in plane B. So they're not on the same plane. They don't intersect. They're not coplanar, so they are skew. Now parallel planes are planes that do not intersect. Plane A and plane B are parallel. If segments or rays are contained within lines that are parallel or skew, then the segments or rays are parallel or skew. So let's look at some examples. Name all the segments that are parallel to BC. So we're looking at BC. So we notice that this one's parallel, this one's parallel, and this one is parallel. So our answer, segment AD, segment EH, and segment FG. Name a segment that's skew to EH. Now we could have a variety of answers here. Our answer, if we look at EH, notice it's on this plane. So anything skewed to it's going to be in a different plane and it won't intersect. So notice AB is going a different direction. CD, BG, and CF, they are all skew. Now when it says name a segment, they're just really asking for one segment. So either one of those answers would be correct. Name a plane parallel to plane ABG. So first of all, let's find out ABG. Looks like you would also have H on it, huh? So we need to know a plane that's parallel to it. What do you think? This is the bottom. So CDE, the top, would be parallel on this cube. Time to check your progress. Name a plane that is parallel to plane RST. So pause for a moment, select your answer, then come back and check. Did you choose plane WXY? Good job. Name a segment that intersects segment YZ. So pause for a moment, then come back and check. Segment XY. Very good. Name a segment that is parallel to RX. TZ, excellent. Okay, now for a new key concept, we're going to discuss transversal angle pair relationships. A line that intersects two or more coplanar lines at two different points is called a transversal. So whenever we're looking at a figure like this, the first thing we need to do is, whatever angles they're talking about, we need to find out which one is the transversal. Notice this blue area is exterior. It's outside of Q and R. Between Q and R, that's called the interior. Okay, and then we have outside of R is another exterior. Line T is the transversal. So let's look at these definitions. There are four interior angles. See, they lie inside the interior region. Angle 3, angle 4, angle 5, and angle 6 lie on the interior. On the exterior regions are angle 1, angle 2, angle 7, and angle 8. Now they're called consecutive interior angles. They're interior angles. They lie on the same side of the transversal. So see, this is the transversal that says consecutive interior, and they lie on the same side of the transversal. So 4 and 5 lie on the same side of the transversal. They're consecutive next to each other. 3 and 6 are also consecutive interior angles. Now there's alternate interior. That means they are non-adjacent, they're not next to each other, and they lie on opposite sides of the transversal. 3 and 5 are alternate interior. 4 and 6 are alternate interior. So let's look at the exterior. There's alternate exterior angles. So notice 1 and 7 are alternate exterior, and 2 and 8 are alternate exterior. And finally, there are the corresponding angles. They lie on the same side of the transversal and on the same side of lines Q and R. So 1 and 5. See, they both lie on the top of Q, top left R. So 2 and 6 are corresponding. 4 and 8 are corresponding, and 3 and 7 are corresponding. Make sure you have all that in your notes. You're going to need that for your assignment. Classify the relationship between angle 2 and angle 6. Angle 2 and angle 6. Well, they're corresponding. They lie on the same side of the transversal. See, the transversal is C. They lie on the same side of the transversal and on the same side of lines A and B. They both lie on the right, bottom right quadrant of lines A and B. How about angles 1 and angle 7? They are alternate exterior. They lie on opposite sides. They're non-adjacent exterior angles, and they lie on opposite sides of the transversal. How about angles 3 and 8? Well, they're interior angles, aren't they? And they're consecutive interior. Very good. One more. Angle 3 and angle 5. Are they on the exterior or the interior of that transversal? They're non-adjacent interior angles, so they lie on opposite sides. They're alternate interior. Very good. Time to check your progress. So classify the relationship of between 4 and 5. So pause for a moment. Check your answer. They lie on the same side of the transversal. They're consecutive interior. How about between 7 and 9? They are corresponding. They lie on the same side of the transversal and on the same side of the two lines. 4 and 7. They're alternate exterior. They lie on opposite sides of the transversal, and they're non-adjacent. Two and 11. Oh, that one's getting trickier now. Our transversal is still P, so pause for a moment and choose your answer. 2 and 11, they lie on the interior of lines L and N. Very good. Ooh, looky here. We've got quite a thing going. When more than one line can be considered a transversal, first you need to identify the transversal for a given angle pair by locating the line that connects the vertices of the angles. So let's look at example 3. The driveways at a bus station are shown. Identify the transversal connecting angle 1 and angle 2, then classify the relationship between the pair of angles. Well, the transversal is going to be V. That's what's connecting those vertices. So we're looking at lines S and X. So they are corresponding angles. Very good. They lie on the same side of their lines. How about angle 2 and angle 3? What's the transversal there? Joining the vertices, that'd still be line V, wouldn't it? So these are alternate interior angles. One more. We're looking at angles 4 and angle 5. Now what's connecting those vertices? Yes, it's line Y. So they're consecutive interior angles. Very good. Let's check your progress. A group of nature trails is shown. Identify the sets of lines to which line A is a transversal. Well, A is a transversal to C, D, E, and F. It's parallel to B, so it's not a transversal to B. How about the sets of lines to which B is a transversal? Very good. C, D, E, and F. It's not A because A is where it's parallel. Very good. How about to which line C is a transversal? Well, C is a transversal to A, B, D, E, and F. There's no line that's parallel to that. Good job. Okay, you're ready to begin your exercises.